Good morning, students. In this video, we'll see about the K-means clustering and how the K-means clustering is implemented in the Python programming. First, what do you mean by K-means clustering? K-means clustering is one of the simplest unsupervised clustering algorithm. It clusters a set of unlabeled data into a specified number of clusters. Idea behind the K-means clustering is first select the centroids. Centroids in the K-means clustering. What does K in the K-means clustering mean? It's the number of clusters. First, select the number of clusters in the K-means clustering. Then the entire data point is grouped into a number of clusters. In my examples, I have selected K equal to 3. So the entire data set is, the entire points in the data set is grouped into 3 different categories. Here, the clustering is done based on the similarity. We know that the similarity can be measured by various terminologies. In our example, we are using the Euclidean distance for finding the similarity between the data points. Euclidean distance is one of the common technique used to find the similarity between the data points. So the similarity between the data points are calculated, and based on that, it's grouped. Main applications of K-means clustering are, one of the main application is used in the Amazon Flipkart to find the target audience. For example, consider establish a pizza delivery centers across the city. There's so many pizza stalls, shops are there. We should identify the pizza boy to deliver the pizza. For that, we can use the K-means clustering to identify the location in which cluster the particular location belonging to. Consider these are the following are the points that the delivery locations are available for the pizza. First point is decide the number of clusters. Here I have taken the number of clusters is equal to 3. And then find the distance between each data point with the clusters. Here, based on the cluster centroid points, all the locations are grouped into some category. After finding that, go and calculate the new centroid. There is no change in the data points after the new centroid also group into a particular cluster. That is the idea behind the K-means clustering. The K-means clustering, we are randomly selecting the value of K. That is, the number of clusters are randomly selected. To find the optimal value of K, we are using one technology or terminology called as the elbow method. Elbow method is one of the techniques used to find the optimal value of K in the K-means clustering. Here, how the data points are moved into a particular cluster that's shown here, a pizza delivery. And it can be summarized as the entire K-means clustering operation is summarized as following. Let us take the data points into the particular selected cluster points. First one is decide the number of clusters. Then second one is calculate the Euclidean distance and assign the data points to the nearest cluster centers based on the minimum Euclidean distance. After that, find the new centroid for each cluster by computing the average of all the data points available inside the cluster. If the new data point is equal to the already existing data point, that is, the new centroid is equal to the centroid in the previous iteration, then stop that. Otherwise, repeat the steps until you get a constant centroid. Start number of clusters, find the centroids, distance of object to the centroids is calculated. The grouping is based on the minimum distance. Centroid has converged, that is the previous iteration and this iteration same centroid is calculated, then end that. Otherwise, repeat the same steps again and again to converge the algorithm. To decide the value of method, we are using the elbow method. This elbow method, this is the curve. For finding the elbow method, do the K-means clustering from K equal to 1 to some iterations and find WCCS value, that is the weighted central sum of square value can be calculated each and every time. Based on that, we are plotting that. Then here, this is the elbow location. This is the convergence locations. So for this example, the best value of K equal to 3. So repeat your same K-means clustering with 3 to get the best answer. This is the way to perform the K-means clustering. These are some advantages of the K-means clustering. It's easy to implement, relatively fast and efficient. Only one parameter to be tuned to get the final values. Here we are using some terminologies. called this WCSS, within cluster sum of square. This is used to find the optimal cluster in the elbow method. And the performance of this k-means clustering can be calculated by using two scores, Celotes value as well as Davis-Bolton index. Celotes value measures how similar an object is to be one cluster. Within the cluster, how the objects are grouped. That is measured by using the Celotes score. If the Celotes score is high, means that is geek that are distributed in a closed manner, means the Celotes score is high, indicates that's better for the k-means clustering algorithm. And Davis-Bolton index measures the size of cluster, again the average distance between the clusters. That is size of cluster and average distance, how far away the values are splitted, that is calculated by this Davis-Bolton index. A lower score indicates the good clustering algorithm. The k-means clustering, the Celotes value must be high and the Davis-Bolton score must be less for the good clustering. Now we will see the Python code for this one. First, import the pandas library as usual for data processing or dataset processing. Then matplotlib is used for plotting the clusters. Then I have taken the k-means cluster algorithm, imported this k-means cluster from this sklearn. We know that sklearn is basically used for all the machine learning algorithms. K-means is also example for the unsupervised machine learning algorithms. Hence, this cluster values are taken. Cluster, this is library function is taken from sklearn Python library. Second step is to load the data set. In my example, I am using the small customer data set. Here I am going to cluster the points based on the attributes age as well as the annual income, or annual income. I will select the annual income and the spending score. This is my data set. For this data set, I uploaded this one. Extracted the values. I am extracting from the mall customer data set. I am extracting annual income and the spending score. That is in the third and the fourth column. I am going to take this third 0, 1, 2, 3. Third one is annual income and the spending score. For this one, I am going to formulate the k-means algorithm. Hence, these two values are taken. So I have extracted third and fourth column by using this iloc operation. The next one is to find the optimal clusters. For finding the optimal clusters, I have to plot the k value as well as the weighted centered sum of square values. You'll see that. So now the values are stored in the X data set, and then create a k-means model. The model can be created. First, give the number of clusters. In my example, I have given the number of clusters equal to 5. You should specify the number of clusters. So in this variable, I have taken k-means algorithm that is imported from the sklearn library, and number of clusters is selected as 5. Now the new data points are predicted. I am predicting the output variable. Output variable is stored in the y predict variable. Y predict equal to, I am fitting my input. Input is assigned in the variable x. So k-means dot fit predict of x. Here there is no need for training as well as testing, because this is the unsupervised. Just I have taken the value, and from that value I am predicting the value of y. Now the value is predicted, y predicted values. Now I should, here there are 5 clusters. So I am going to scatter, using the scatter plot, I am going to plot all these center points. So I am using the plotters scatter plot. Scatter plot is here there are 5 clusters. So I'm using this one to find the clusters. Here I'm using 5 different clusters. So I'm using 5 different colors for plotting that one. First one is for the first cluster, second is for the second cluster, third, fourth, and go on. So I'm plotting the cluster centroids also. For plotting the centroids, I'm using the centroids. Centers equal to k-means cluster centers. All the cluster centers are assigned to centers, and I have plotted the centers also. Here, this is the cluster. For annual income, I have plotted for annual income as well as the spending score. Based on that, that is all the data points are divided. This one here, the yellow dot indicates the center points. These are the center points of the cluster, and again remaining 5. These 5 are the cluster centers. Here scatter plot is used for this one, and the centroids are also stored here. Then I already told you that can be measured. The performance can be measured by 2 score, Celotti score as well as David Bolston score. By using this score, I have calculated this score also 0.554 and 0.573. This Celotti score must be less and the David Bolton must be high. So here it's in the average rate. You can see here the values are scattered. If it is a good score, if dB is good, then that is stored in the compact manner. Then to find the optimal value, here I already told you to find the optimal value is very, very important. I have, to find the optimal clusters, we are using the elbow method. For executing the elbow method, I have created on list WCSS. Here all the values of this within clusters, sum of square values are stored up and down one by one for different values of K. For that one, I am using the for loop. In the for loop, I have implemented the K-means algorithm with different values of K. Here the model used is the K-means algorithm, and number of clusters is I. I may vary from 1 to 11. For 11 different values, I am using this elbow method. Then I am following this K-means plus, incrementing this one, and maximum iteration 300, n in it equal to 10. How often algorithm will run with different values, and random state equal to 0, which indicates that we are using the same data points for reproducibility. And fit the model with this input X. I have selected 2 columns for the input and append the array. Append the array with different values of this K and the WCSS. Then plot that one. When I am plotting this one, I am getting within cluster sum of square values that is available in the array, and number of clusters with the help of for loop. I have implemented the cluster values from 1 to 11. When you see this elbow method in here, the number of clusters identified is after this point, it remains constant. It indicates that number of clusters K equal to 5. So the optimal value here is 5. I may implement this same K-means algorithm with different values of K. You implement with different values of K and see the performance scores, that is dB, and as well as the Celotti score. You will find which one is the optimal one. Based on our data set, the K equal to 5 is the best one. So that's all about the K-mean algorithm. Thank you.